Hi guys, you have just finished your vertex form quiz, and I hope you feel confident about that. If not, I want you to look back at the video that I recorded yesterday for the vertex form, specifically for that quiz, okay? What you're looking at on your screen is a graphic organizer for Unit 3, and if you don't already have that, you're going to get that from me today. We have been working in the graphing quadratic functions portion of our unit. We've also been working in the key features portion of our unit, and I'm going to talk to you today about a specific key feature, two of them, that we haven't touched on yet, okay? But it's not something totally new. You talked about it back in Algebra 1. Okay, so you can see we're on this key features side. The key features we've already talked about are shown up here in this graph. We've talked about axis of symmetry, the vertex, how quadratic functions or parabolas have zeros, and the y-intercept, that every quadratic function will have one of those. What we haven't talked about is the domain and range of a quadratic equation. And that's what I'm going to talk to you about here. So if you think back to Algebra 1 and domain, you probably just remembered that domain is your x values. And that was probably about it. That was all you did. You had a table and you had to say, these are my separate x values. You also looked at that with a line and a linear equation, and you would have had to have stated the domain for that. This is going to be like that domain, okay? When we talk domain, instead of just saying it's the x's, you have to be asking this question: how far left to how far right does the curve extend? Okay, how far left does it go? How far right does it go? Those are our x directions. For range, you probably thought about that. Well, if domain is x, range must be y, as the y values, and that's not untrue. But I want you to start asking this question: how low to how high does it go? How far down to how far up? Okay? Left is negative for x's, right is positive for x's, down is negative for y's, up is positive for y's. In that order: how far left to how far right, how low to how high. Okay, keep those two questions in your mind as we go through today. Okay, so I've shown a parabola for you here, and I want you to notice a difference that I have put in pretty obviously on this parabola that you haven't been seeing on your graphs, okay? But in Algebra 1, if you didn't have this in there, then your graph was not completely correct. Any idea what that is? If you're thinking the arrows, you are right on target. Okay, so when we think about domain and range, we need, along with asking those questions, how far left to how far right, okay, we need to use the arrows to help us answer those questions. So if you're looking at this arrow, I want you to think, what direction or multiple directions is this one arrow actually pointing? Okay, most of you are probably thinking up, and you would not be wrong. But if I am thinking about domain, up is not a domain direction. Up is a y direction. That would be range. Okay, so what other direction is this arrow pointing? It's pointing up, but it's also tilted to the left. Okay, and remember that the arrow means that it just doesn't just go to the left for a little bit. It actually extends to the left forever. Okay, it's going to the left forever. All right. As far as the other arrow goes, I want you to think about what two directions it goes. This arrow obviously goes up. Again, that's a range direction, but if we're thinking domain, it also goes right. Okay, so we have the one arrow that's pointing left, the other arrow that's pointing right, and those are actually going left and right forever. And that would be true for any parabola. Any parabola that has a U-shape, just like this, that's what makes it a parabola. And one arrow will point left forever, and one arrow will point right forever. The awesome thing is that means that the domain is the same for every parabola. So it's not sometimes it's this, sometimes it's that. It's the same for every parabola. Okay, now set builder notation is what you were probably most used to in Algebra 1, and how you would write the domain. If it's saying left forever, right forever, you would write it in this set builder notation. Okay, so if I could press each of these characters, each of these symbols to make a sound, this one would say the set. That's what you say with the curly brace. Of x's, and then this big tall line says such that. So the set of x values such that x is in the set of real numbers. Okay, the domain part of this is x is in the set of real numbers. Okay, I say it's like a birthday present or a Christmas present. The wrapping is nice, but what you really care about is what's on the inside. And what's on the inside of this is x is in the set of real numbers. That's your domain for every parabola. Another notation that we're going to be using in Algebra 2 is called interval notation. Interval notation takes the domain and it writes it in 5 to 7 characters. And that's a whole lot less characters than having to write x is in the set of real numbers, each of those letters being a character. So the interval notation looks like an ordered pair, but it is not an ordered pair. Looks like it, but it isn't. It's in a different context, okay? Think about in English. You use an apostrophe sometimes for a contraction. Don't do that. Don't there is used, the apostrophe is used as a contraction. But you can also use the same apostrophe as a possessive, okay? Attaching, to the end of someone's name. Okay, so apostrophes as possessive or as contractions. Here, this notation can be used to be an ordered pair, but in this case, it's used as an interval notation. And what you have to do with every domain, for a parabola or otherwise, is ask yourself the question I said at the beginning. How far left does this extend? How far right does this extend? Okay? Now, the left forever number, forever, I want you to think about Buzz Lightyear, that infinity. The left, if you go left forever, left is a negative direction, then you have negative infinity. Sorry, that's not formatted correctly. Sorry, guys. I don't know. All the characters got mixed up. So took a break, fixed that, and here you have it in front of you. So the interval notation, how far left does it go? Well, it extends left forever. And that means it extends to negative infinity as far as x is concerned. To the right, it extends to the right forever, and that's positive infinity as far as the x is concerned. Okay, so it goes from negative infinity to positive infinity. That is another way to say the domain of this parabola. Okay, now for the range, that's just a little bit different. Okay, it's not quite as cut and dry as the domain is. Again, we're going to have two possible notations, set builder and interval, but you have to ask a second key question here. Aside from the how low to how high does it go, you have to ask yourself, is the vertex for each parabola, for this one that you're looking at on the screen, is it a minimum or a maximum? Okay, so remember your vertex is right here. And I want you to think for a second if you would say that this is a minimum or a maximum, and why? Okay. If you're not done thinking, press pause. This one, notice how the vertex is at the bottom of your parabola? Bottom would be a word that would go with minimum. The minimum is actually the lowest y value on this parabola. This arrow pointed up forever. This one pointed up forever, okay? But it doesn't go down forever. It bottoms out right here at the vertex, okay? So if you have a minimum, then your set builder notation is going to look like this. The set of all y values such that the y's on the parabola are all greater than or equal to, and then you put what that minimum value is. In this case, it would be the -1 that goes with the y value of that vertex. Okay, all of the other y values in red and the arrows, they are all greater than or equal to this -1. Okay, I'll talk to you about a maximum in a minute. As far as the interval notation goes, okay, the interval notation, we will again have something that looks like an ordered pair. That's what interval looks like, except we don't ask how far left to how far right, because that's not a y direction. We now put the lowest value to the highest y value we get. And for this one, it will be -1 is the lowest to positive infinity is the highest. That's that up forever. Whenever you think or say forever as far as a math direction, you need to be thinking infinity and attaching infinity to the word forever. Okay, now have any of you noticed that we have a square bracket there instead of a parenthesis? And when do we need a square bracket and when do we need a parenthesis? Okay, the square bracket we use because the y value actually equals -1 at the vertex. It really does equal -1. We have a square bracket on the -1 for the same reason that we have an equal to on the range for the set builder. Y is greater than or equal to -1. This means or equal to -1. -1 is the lowest. Now, as far as infinity is the highest, your y's can only approach that forever number. They can only approach positive infinity, but they will never actually equal positive infinity. You think of the biggest number you can possibly think of, and you can always add 1 to it. You could always multiply it by itself. You can always get bigger. You will never actually reach infinity, and that's why we have the parenthesis on the infinity side. Always a parenthesis on the infinity, a square bracket on the number if it actually equals that. Okay? Now, I'm going to pop back here in a second to talk to you about maximum. But let's do a couple of examples from the big vertex form packet that you've been working on. It had the understanding questions as 1 through 8 on the front, and then you opened it up and you had these graphs. And these are graphs 3 and 8 from that. Your assignment for Thursday is going to be to state on 1 through 10 on these graphs, state the domain and the range. Okay, and I would like for you to show those both with set builder and with interval to get used to the two of those. And then after this, you'll be able to choose which one you like the best, but you need to be able to do both. So we're going to do both today. Okay, so the domain, let's start with number 3. Left forever, right forever. The domain, all real numbers or negative to positive infinity. That should look more like an ordered pair. My stuff is off again. The range, okay? Remember, it's how low to how high. This has a minimum, and the minimum value is y equals -5. So the range is y values greater than or equal to -5. As far as the interval notation, that is lowest is -5, so that's going to go on the left. And then the highest is positive infinity. And again, I apologize for the notation there. Okay, I have just a few seconds left to talk to you about this one. Still a parabola, domain and range will never change. Or domain will never change. The range, on the other hand, because this vertex is a maximum as a top instead of a minimum as a bottom, this range is not all of the y's on this are bigger than this y value of 0, but instead all of them are less than this value of 0. Okay? And then the range, I know this is going to be messed up, and I'm sorry for that, but this time the low is going to be negative infinity because it goes down forever, and the how high is going to be 0. So you're going to see these switched around. It should be negative infinity on the left, comma, 0 on the right. I'm going to write these correctly on the board, and I want you to jot these down so that you're not confused anymore, okay?